Greetings of the day. My name is Nikhil Pandey, and I am from MCA branch of Vellore Institute of Technology, Chennai. I am here to discuss about basic concepts of computer networking. So, in this discussion, we will be discussing about networks and its basic concepts, uses of networks in sharing of resources and backups, common types of networks, LAN, WAN, Internet, etc., network media, wireless networks, threats to network, the internet world, and the cloud and cloud computing. So first of all, what is the computer network? So when the two devices or two or more devices connect through each other to share a resource or data is called a computer network. So in the theoretical definition, that computer network is a group of computer devices that use a set of common communication protocols over digital interconnection for the purpose of sharing the resources located on or provided by the network nodes. So what is nodes? So the nodes of a computer network may include personal computers, servers, networking hardware, or other specialized or general purpose hosts. So basically, we can say that every device participating in a connection, network connection, is called nodes. And then the interconnection between the nodes are formed from a broad spectrum of telecommunication network technologies based on physically wired, optical, and wireless technologies. A communication protocol is a set of rules for exchanging information over a network. So this is the basic network diagram I have used to illustrate different kinds of networks. Then coming to the advantages or uses of a network. So first is simultaneous access. So there are many moments in any business when several workers may need to use the same data at the same time. So while you connecting to a single network, we can use it. Then shared peripheral devices. Like it's not possible to in a large enterprise facility to provide separate peripheral devices to the separate employees. Like there are thousands of employees. We can't provide thousands of printers and scanners to the thousands of employees to use them separately individually. So what we can do or what they do actually is they connect every computer to that single printer so that they can use the printer and they can save the cost of buying of thousands of printers. Then coming to personal communication. The personal communication means we can do video conferencing through network like in the meeting our CEO is sitting at different country that still we can do interaction and meeting with them. It is done by voice over internet protocol. Then comes easier data backup. So data backup is very easy in networking. Like if we have three computers and they all are connected in a network and we back up data in the different computers and our computer gets corrupted. So then also we can retrieve the data from another computer when the new system gets installed or etc. So coming to the network devices nodes. So there are several network devices. So here I'm listing some devices I'll be discussing in the next slide. First is NIC card, second is repeater, third is hub, fourth is switch, fifth is bridge, sixth is router, seventh is gateway, and eighth is firewall. So first of all, what is network interface card? So interface card, commonly known as NIC, is used to physically connect host devices to the network media. So NIC is a printed circuit board that fits into the expansion slot of a bus on a computer motherboard. It can also be a peripheral device. NICs are sometimes called network adapters. Each NIC is identified by a unique code called a media access control address, which is also known as MAC address for easy understanding. So this address is used to control data communication for the host on the networks. So using MAC address, we can track the computer or we can if you regulate our data communication using the MAC address. Every device connected to a network or our phone, our laptop has a MAC address. Then comes repeater. So what happens when we want to send data from one place to another and the second place is very far away from the host? So or she installs a repeater in the between. So because when the when the data is passing through signals, it loses its strength time by time. So by installing a repeater, we just amplify the signal so that it don't lose its strength and we, it, the receiver gets accurate data as sent by the sender. So here is the critical knowledge. A repeater is a network device used to regenerate signal as a tool. A repeater regenerates analog or digital signals that are distorted by transmission loss due to attenuation. A repeater does not make an intelligent decision concerning forward packets. Now coming to the hubs. So hub concentrates on connection. In other words, we can say that they take a group of hosts and allow the network to see them as a single unit. So this is done passively without any other effect on the data transmission. Active hubs concentrates hosts and also regenerate signals. Now coming to bridges. So bridges is basically in real life also what is the use of bridge? So bridge is basically used to cross the like he- this side one road is that side one road is in between the river is there. So bridge is used to connect the both roads. Here also it is doing the same. See in this illustration. Here one hub is connected to separate network and below one hub is connected to another network. And the bridge is the pathway between the two networks. So coming to the theory, bridges convert network data format and perform basic data transmission management. Bridges provide connection between LANs. They also check data to determine if it should cross the bridge. This makes each part of the network more efficient. Then comes switches. The switches adds more intelligence to the data transfer management. They can determine if data should remain on a LAN and transfer data only to the connection that needs it. Another difference between bridge and a switch is that a switch does not convert data transmission formats. Then comes router. So basically, router have all the capabilities listed in the previous slides, and router can regenerate signals, concentrate multiple connections, convert data transmission formats, and manage data transfers. They can also connect to a WAN, which allow them to connect LANs that are separated by great distances. Now coming to the gateway. So what is gateway? Gateway is the hardware used in telecommunication for telecommunication network that allows data to flow from one district network to another district network. Gateway are distinct from routers or switches in that they communicate using more than one protocol to connect a bunch of networks. Then comes firewall. Firewall, we all know that firewall is used to protect our devices from any attack or any malicious websites that is available on internet. So here a firewall is a network device or a software for controlling network security and access rules. Firewalls are inserted in connection between secure internal networks and potentially insecure external networks such as the internet. Firewalls are typically configured to reject access requests from unrecognized sources while allowing actions from unrecognized ones. The vital role firewall play in the network security grows in parallel with the constant increase in cyber attacks. Now coming to network media. So the function of network media is to carry a flow of information through a LAN. So type of network media is wired media. So widely adopted family that uses copper and fiber media in local area network technology are collectively known as Ethernet. So first is copper cable. In copper cable, there are three main types of copper cable like coaxial cable, shielded twisted pair cable, and unshielded twisted pair cable. And second one is fiber optics cable. And the second type of network media is wireless media. And wireless media, as you all know, it's Wi-Fi, Bluetooth, internet, etc. that uses the atmosphere space as the medium. Now coming to copper cable. So copper cable is the most common, easiest, quickest, and cheapest form of network media to install. The disadvantage of sending data over copper wire is that the further the signal travels, the weaker it becomes. Here we need repeater the most, as I told in the previous slide, why we need repeater to overcome this disadvantages specifically. Now coming to the first type of copper cable, that is coaxial cable. Here in the diagram you can see that there is an outer jacket, then the braided copper shielding, then a plastic insulation, then a copper conductor. And this copper conductor is very delicate and it is used to transfer data. That is why this all the shields are used to protect this particular cable, which is the lowermost part of the cable. So it can be run longer distance than a twisted pair cable. Its speed is 10 to 100 Mbps. It is very cheap media and connector size is medium and maximum cable length is 500 meters. Then comes shielded twisted pair, that is STP. It consists of jacket, then braided shield, then foil shield, and then twisted pairs of cable. So its speed is 0 to 100 Mbps. Its cost is neither too expensive nor too cheap. It's moderate. Median connector size is medium to large. Maximum cable length is 100 meter. Then comes unshielded twisted pair. So UTP, it is commonly known as UTP. So UTP is a four pair wire medium used in a variety of networks. Like here we can see outer jacket and then direct wire is starting. Like outer jacket protects it from physical damage and that twisted pair protects it from signal interference. So you so each of the eight copper cable, here you can see eight copper cables. Wire in the UTP cable is covered by insulating material and its speed can vary from 10 Mbps to 100 Mbps and goes up to 1000 Mbps. It is least expensive and its media connector size is small and its maximum length is 100 meter means depending on the quality of the cable it may break in the between or something like that. So this is the kind of UTP cable. You may see similar kind of cable in the telephone wires and the internet connections if you have a broadband connection at your home. And see, EIA specifies an RJ45 connectors for UTP cable. Here RJ stands for restricted jack. Then comes fiber optical cable. So in this, the glass fiber carries light pulses, each pulse in a beat. It is based on the total internal reflection of light. It is very high speed. It can go from 10 Gbps to 100 Gbps speed. It has low error rate and the repeater are spaced far apart. Like we don't need repeater actually to transmit data every now and then because it don't lose its strength for a longer period of time. And it is immune to electromagnetic noise. Means electromagnetic noise don't affect fiber optic cable that much. Now coming to communication protocols. So communication protocol, as I told before, is the set of rules that is used to connect the networks. So first type of communication protocol is Internet Protocol Suite, also called a TCP/IP. It is the foundation of all modern networking. It defines the addressing, identification, and routing specification for IPv4 and IPv6. It is the defining set of protocols for the Internet. Then comes IEEE 802. It is the family of IEEE standards dealing with local area networks and metropolitan area networks. They operate mostly at the level 1 and 2 of the OSI model. Then comes Ethernet. It is a family of protocols used in wired LANs described by a set of standards together called IEEE 802.3. So this is the proper architecture of TCP/IP protocol in which layer which part is belonging like the application is HTTP, FTP is belonging. in transport layer, TCP belong like that. Now coming to the communication protocols again. So first is wireless LAN. It is standardized by IEEE 802.11 and shares many properties with wired Ethernet, SONET and SDH, synchronous optical networking, and synchronous digital hierarchy are standardized multiplexing protocols that transfer multiple digital bit streams over optical fiber using lasers. Then comes asynchronous transfer mode. It uses asynchronous time division multiplexing and encodes data into small fixed size cells. Then comes good choice for a network that handles both traditional high throughput data traffic and real-time low latency content such as voice and VT. Now coming to the types of network. So there are different types of network. I'm listing here every network and I'll be explaining for the next slide. So first is personal area network, then is local area network, then campus area network, metropolitan area network, wide area network, storage area network, virtual private network, client server network, peer-to-peer network. Now coming to personal area network. Here is the basic illustration of personal area network. I got it from Google. So personal area network is a computer network used for data transmission among devices such as computer, telephone, tablet, and personal digital assistants. Then coming, it is also known as home area network. Home area network because it is basically or mostly used in the home. Like today, smart home is taking place. So we connect our AC, our TV, our mobile phone to a single broadband services or Wi-Fi. That is also a type of personal area network. So PAN can be used for communication among the personal devices themselves or for connecting to a higher level network and the internet where one master device takes up the role of internet router. Then comes local area network. Here I have showed local area network illustration. So Xerox Corporation worked in collaboration with DEC and Intel to create Ethernet, which is the most pervasive LAN architecture used today. Ethernet has evolved and has seen significant improvement in regards to speed and efficiency. An upside of a LAN is fast data transfer with data speed that can reach up to 10 Gbps. Other significant LAN technology are fiber distributed data interface and token ring. Then comes campus area network. So campus area network are larger than LAN but smaller than metropolitan area network. These type of network are typically seen in university or large theater, school district or small businesses. Like in this diagram, you can see a campus building is connected with building 1, building 2, building 3, and hostel zone like that. They can be spread across several buildings that are fairly close to each other so user can share resources. Then comes metropolitan area network. So metropolitan area network is larger than LAN but smaller than or equal to the size of wide area networks. So the size ranges from 5 to 50 kilometers in a diameter. MAN are typically owned and managed by a single entity. This could be an ISP or telecommunication company that sells its services to end user in that metropolitan area. For all intents and purposes, a MAN has the same characteristics as a WAN with distance constraint. Then coming to wide area network, as we all know wide area network internet. So wide area network exists over a large area. Data travels through Data travels through telephone or cable line, usually required the world's largest wide area network in the internet. Storage area network. So SAN may be referred to as sub-network or special purpose network. It is the special purpose is to allow user on a large network to connect various data storage devices with cluster of data servers. So SAN can be accessed in the same fashion as a drive attached to a server. Then comes VPN, or we can say virtual private network. So VPN is a private network that can access public network remotely. So VPN uses encryption and security protocols to retain privacy while it accesses outside resources. So when employed on a network, VPN enables an end user to create a virtual tunnel to a remote location. Typically, telecommunicators use VPN to log into their company from their home, or it is mostly you can work from home nowadays after COVID era. So it has some property like authentication is provided to validate the identities of two peers, then confidentially provides encryption of the data to keep it private from prying eyes. Prying eyes means hackers. Integrity is used to ensure that the data sent between two devices or sites has not been tampered with. Now coming to client server and network. So in a client server arrangement, network services are located on a dedicated computer called a server. This server responds to requests of a client. The server is a central computer that is continuously available to respond to the request of client for file, print, application, and other services. Most network operating system adopts the form of client-server relationships. Typically, desktop computers functions as client on one or more computer with additional process power, memory, or specialized software functions as servers. Now coming to P2P network, also known as peer-to-peer networks. So usually very small networks, as you can see in the diagram. Each workstation has equivalent capabilities and responsibilities, does not require a switch or a hub. These type of network do not perform well under heavy data load. Means if the data loads increases, the system might crash or data loss may happen. Now coming to the network topologies. So network topology is nothing but the structure or the design of a network in which the networks are arranged, or we can say nodes are arranged. So first of all, there is physical topology. It is defined actual layout of wire or media. Like there are several types like bus topology, ring topology, star topology, trees or hierarchical topology, and mesh topology. Then comes logical topology. It defines how the host access the media to send data, like broadcast or token passing. Then comes hybrid topology, which is a mixture of both. First comes the bus topology. So here is the illustration of bus topology. So all the devices are connected to a central cable called as bus or backbone. Then there are terminators at each end, the bus that stop the signal and keep it from traveling backwards. Advantages. There is no central controller resides in each station. The third advantage is the less interconnecting wire is required for its ease of installation. And fifth is backbone cable can be laid along the most efficient part and then connected to the node by dropping lines of various length. Now coming to the disadvantages. So it is possible that more than one station may attend transmission simultaneously. So it may lead to collision or contention or data loss. Difficult configuration and fault isolation. A fault or break in the bus cable stops all the transmission even between devices on the same side of the problem. The damaged area reflects signal in the direction of origin, creating noise on the both directions. So finding the fault is very difficult here. Then coming to ring topology. Ring topology, all devices are connected to one another in the shape of a closed loop. Each device is connected directly to other devices on either side of it. So advantages of ring topology avoid the collision that are possible in the bus topology. Each pair of station has a point-to-point connections. A signal is passed along the ring in one direction from device to another until it reaches its destination. Each device incorporates a repeater. relatively easy to install or reconfigure. Fault isolation is simplified, but the disadvantages are a break in the ring can disable the entire network, and it is unidirectional traffic. But because you need a unidirectional traffic to regulate the traffic more efficiently, but that's not possible in the ring topology. Now coming to star topology. So in star topology, all the devices are connected to a central hub. So nodes communicate across the network by passing through the hub or switch. So advantages of star topology is it is easy to install and reconfigure. Robustness. If one link fails, only that link is affected. All the remaining links will be active. Easy fault identification and isolation. As long as the hub is working, it can be used to monitor link problem and bypass defective links. Now coming to disadvantages. The devices are not linked to each other. If one device wants to send data to another, it sends it to the controller, which then relays and the data to the other connected device. Now coming to tree or hierarchical topology. So in these the advantages are it allows more devices to be attached to a single central hub and can therefore increase the distance a signal can travel between devices. It allows the network to isolate and prioritize communication from different computers. Now coming to the disadvantages. So the disadvantages the devices are not linked to each other. If one device wants to send data to another, it sends it to the controller, which then relays the data to the other connected devices. Now the third point is the addition of secondary hub brings two further advantages. Now coming to mesh topology. So in the mesh topology, each host has its connection to all other hosts. So mesh topology is implemented to provide as much protection as possible from interruption of services. Like a nuclear power plant might use a mesh topology in the network control system. Although the internet has multiple paths to any one location, it does not adopt the full mesh topology. So the advantages are the use of dedicated links guarantees that each connection can carry its data load, thus eliminating the traffic problem that can occur when links must be shared by multiple devices. Second, it is robust. If one link becomes unusable, it does not incapacitate the entire system. Third is privacy and security. Like every message sent travel along a dedicated line, only the intended recipient sees it. And the fourth advantage is point-to-point link make fault identification, fault isolation very easy. But there are some disadvantages also, like the large amount of cabling is required, and the large amount of input-output ports are required. Installation reconfigurations are difficult. The sheer bulk of the wiring can be greater than the available space. The hardware required to connect each link can be prohibitively expensive. Now coming to the wireless networks. So wireless network is a type of network that uses wireless data connection for connecting network nodes. Like example, Bluetooth and Wi-Fi. So first of all, what is Bluetooth? As we all know, Bluetooth is a short-range wireless technology standard used for exchanging data between fixed and mobile devices over a short distance. It is using UHF radio waves in the ISM bands from 2.402 GHz to 2.48 GHz. Now coming to the IEEE standardized Bluetooth as IEEE 802.15.1 but no longer maintains the standard. Then coming to Wi-Fi. Wi-Fi stands for wireless fidelity. Now Wi-Fi is a local area wireless technology. So Wi-Fi network are radio technologies to transmit and receive data at high speed. It is based on IEEE 802.11 family of standards. So first of all, what is the access point? So the access point is a wireless LAN transceivers or you can say base stations that can connect one or many wireless devices simultaneously on the internet. So what is internet? So internet I've shared basic packet how the internet is shares the information. So the green part is the header. Header provides a complete destination address for the packet. Second is data block, that is depicted in yellow color. The portion of the overall information carried by a packet. And red one is sequence ID. ID where the information belong in the relation to the rest of the information. Then it is covered with end packet, that is covered with yellow at the end. ID is the end of the packet. So in the simpler definition of the internet is that it's the network of computer networks. So like for example, I can say a page on the internet, whether it's full of words, images, both, doesn't come to you in one shipment. It is translated into digital information, chopped into 1500 byte pieces called packets, and sent to you like a puzzle that needs to be reassembled. Each part of the packet has a specific function, like told you in the starting. So the internet. So how information travels through the internet? Here is the basic diagram of like how computer contact with ISPs and ISP contact to routers and web servers. So I can say when you connect to a website through an ISP and start exchanging information, there isn't a fixed connection between your computers and the web server's computer hosting the websites. Instead, information is exchanged using the best possible path at that particular time. Special computers called router determine these paths, avoiding slow links and favoring fast ones. So first, cloud computing. So cloud computing is a internet-based computing whereby shared resources, software, and informations are provided to computers and other devices on demand, like the electricity. A cloud is a type of parallel and distributed system consisting of a collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources based on service level agreements established through negotiation between the service providers and the consumers. Properties and characteristics. First is scalability and elasticity. Second, availability and reliability. Third is performance optimization. Fourth is access portability. Fifth is manageability and interoperability. Now coming to IaaS. So IaaS is commonly known as infrastructure as a service. So the capability provided to the consumer is to provision processing storage networks and other fundamental computing resources where the consumer is able to deploy and run arbitrary software, which can include operating system and application. The consumer does not manage or control the underlying cloud infrastructure, but has control over operating system, storage, deployed application, and possibly limited control of select network components. PaaS, Platform as a Service. So the capability provides to the consumer is to deploy onto the cloud infrastructure consumer created or acquired application created using programming languages and tools supported by the provider. So the consumer does not manage or control the underlying cloud infrastructure, including networks, servers, operating systems, or storage, but has control over the deployed applications and possibly application hosting environment configurations. Then coming to SaaS, that is software as a service. The capability provided to the consumer is to use the provider's application running on a cloud infrastructure. The applications are accessible from various clients devices through a thin client interface such as web browser. So the consumer does not manage or control the underlying cloud infrastructure, including networks, servers, operating systems, storage, or even individual application capabilities, with the possible exception of limited user-specific application configuration settings. Cloud deployment models. So there are four primary cloud deployment models. One is public cloud, second is private cloud, third is community cloud, and the fourth is hybrid cloud. So this is the difference between public cloud and private cloud because these two are mostly used. And at last, I would like to thank you all for giving me this opportunity to present this topic in front of you. Thank you.